right, so for lesson 5, we're going to be talking about taking derivatives of transcendental functions. So transcendental functions, that is our trig, our exponential, and our logarithmic functions. So we're going to start off with the trig functions. So I have my 6 trig functions there and their respective derivatives. So if I want to differentiate these, first I have f of x is 2 sine x minus 5 cosine x. My derivative, f prime x. So the derivative of sine is cosine, so 2 cosine x minus 5, and then the derivative of cosine is negative sine x. So that gets me f prime of x is 2 cosine x plus 5 sine x as my derivative there. Okay. All right, next one I got f of x is negative secant x plus 3 cotangent x. So my derivative f prime, so the derivative of secant is secant tangent. So I have negative secant x tangent x. Plus then 3 times the derivative of cotangent is negative cosecant squared x. So simplifying that, I got negative secant x tangent x minus 3 cosecant squared x. All right, next up I got 3 cosecant x minus 2 tangent x. So this is again just working with those derivatives, nothing too crazy. So the derivative of cosecant is cosecant cotangent. So I got that the derivative here is negative 3 cosecant x cotangent x. And then the derivative of tangent is secant squared. So then this is minus 2 times secant squared x. And there's g prime of x. Now, getting into rewriting with some trig properties that we know in trig identities. So I have f of x is 4 sine x over 2 cosine x. So a little reminder that we need to make sure we remember from pre-calc. We can rewrite sine over cosine as tangent x. So I'm going to rewrite this function f of x. 4 divided by 2 is 2. And then, like we said, sine over cosine is tangent, so 2 tan x. And then I can just do the derivative there, f prime of x. The derivative of tangent is secant squared. So this is going to be 2 secant squared x. Okay, going ahead to my next one. So I got 3 over sine t plus 1 over secant t is h of t. So again, important trig identities to remember. So the reciprocal of sine is cosecant. And then the reciprocal of secant is cosine. So what I'm going to do is I'm going to rewrite this function. So I got h of t is 3 cosecant x, or cosecant t, plus cosine t. And now I'm going to go ahead and derive that. So h prime of t, derivative of cosecant is negative cosecant cotangent. So I got negative 3 cosecant t cotangent t, plus then the derivative of cosine is negative sine. So then minus sine t is that derivative. And then for my last one, so I got f of t is negative 2 cosecant t minus 3 cosine t divided by 4 sine t. So the reciprocal of cosecant is sine. So that's that important pre-calc reminder. And then I can rewrite cosine over sine as cotangent. So I'm going to first rewrite my function as negative 2 sine t minus 3/4 cotangent t. And I'm just going to go ahead and derive now. So f prime of t, the derivative of sine is cosine, so negative 2 cosine t. Derivative of cotangent is negative cosecant squared, so negative is going to be positive 3/4 cosecant squared t. And there's my derivative. So these aren't too difficult. It is a good idea to start memorizing these. And do not forget the pre-calc reminders of how you can rewrite trig functions. All right, so I got f of x is 2 sine x plus tangent x. I want to find my exact value of f prime of pi over 4. So I do need to start. I got to find my derivative. So f prime of x. So 2 sine x, so the derivative of sine is cosine. So this is going to be 2 cosine x. Plus the derivative of tangent is secant squared. So plus secant squared x. So I now want to do f prime of pi over 4. So I got 2 times the cosine of pi over 4 plus secant squared of pi over 4. So remember pi over 4 in the unit circle, radical 2 over 2, radical 2 over 2 are my coordinates. So I know that the cosine is radical 2 over 2. And the secant, so the reciprocal of my cosine. So the reciprocal would be, as a reminder, 2 radical 2, which when we rationalize gets us 2 radical 2 over 2, which crosses out, which leaves me radical 2. So then this is plus radical 2 squared. And I'm going to go ahead and simplify this down. So for my first, the 2's cancel out, which leaves me radical 2. And then radical 2 squared is 2. So this would be my exact answer, radical 2 plus 2. All right, so that's our trig derivatives. Now let's get into exponential and logarithmic. So if I want to differentiate an exponential function of the form a to the x, its derivative is the exponential function times the ln of the base of my exponential. The derivative of e to the x is e to the x times, again, that ln of e, which just simplifies to e to the x. So the derivative of e to the x is e to the x. The derivative of a log base a of x is 1 over x times the ln of a. And then the derivative of the natural log of x, so you see, is that it's 1 over x times the ln of e, but remember that the ln of e, these are inverses, so this is just 1, which means that the derivative of ln of x is 1 over x. All right, so differentiating these. So I got f of x is 2 to the x plus 3e to the x. So this gets me f prime x is the derivative of 2 to the x is 2 to the x times the ln of 2 plus then 3e to the x. The derivative of e to the x is e to the x. So plus 3e to the x. And there's my derivative, and I'm done. So I got my next one, 4 to the x minus 9e to the x. So I got f prime of x. Again, the derivative there is going to be my exponential times the ln of the base. So times the ln of 4 minus the derivative of that is 9e to the x. Okay. All right, now getting into the logarithmic ones. So I got log base 4 of x plus 4 times the ln of x. So I got g prime of x, so I'm going to start log base 4 of x, so this is 1 over x times the ln of the base, so times the ln of 4, plus then 4 times the derivative of ln of x, which is 1 over x. So I'm going to rewrite this as 1 over x times the ln of 4 plus 4 over x. So there's my derivative. Next one, I got 5 ln x minus 2 times log base 3 of x. So I got f prime of x. So this is again 5 times the ln of x derivative, which is 1 over x. Minus, I got 2 times the derivative of log base 3 of x, which is 1 over x times the ln of 3. And then I'm just going to write that a little bit nicer. So 5 times 1 over x is going to be 5 over x minus 2 over x times the ln of 3. And this is my derivative here. All right. All right, so now I have this function 2 ln x minus 5e to the x. I want to find the slope of the line tangent to f of x equals 1, and I'm going to approximate the slope to the nearest thousandth. So remember, the slope of the tangent line is always the derivative. So I'm going to find the derivative, and I'm going to evaluate it at 1. So I got f prime of x, the derivative of 2 ln x is 2 over x, minus the derivative of 5e to the x is 5e to the x. And now what I'm going to do is I'm going to do f prime of 1. So I got 2 over 1 minus 5 times e to the first, which is 2 minus 5e. And we can go ahead and put that in a calculator. 2 minus 5e. And that gets me approximately negative 11.591. So that would be the slope of that line tangent to that function when x is 1. All right, so finding the equation of the tangent and normal lines. So I got my function is 3 cosine x plus x, and I want to work with this when x is pi over 2. So remember, we have our tangent line equation. So I got y minus f of c equals f prime of c times x minus c. And then remember the normal line. The only thing that's different is I have negative reciprocal slopes since the normal and tangent lines are perpendicular. So this is going to be y minus f of c equals 1 over f prime of c times x minus c. All right, so to find these, I need to find the derivative. So I have f prime of x. So the derivative of cosine is negative sine, so this is going to be negative 3 sine x. And then the derivative of x is 1, so plus 1. Okay. Now I need to evaluate my function and my derivative at my x value. So I'm going to do f of pi over 2. So this gets me 3 times the cosine of pi over 2 plus pi over 2. So then I'm going to go ahead and I am going to evaluate this. So 3 times the cosine of pi over 2, which is 0, plus pi over 2. 0 plus pi over 2 is pi over 2. I'm going to also evaluate my derivative, so f prime of pi over 2. So I get negative 3 times the sine of pi over 2 plus 1. So the sine of pi over 2 is 1. So I have negative 3 times 1 plus 1. Negative 3 plus 1 is negative 2. Okay. So now what I'm going to do is I'm going to go ahead and plug everything in to my tangent and normal line equations. So for my tangent line, I have y minus evaluated in the function, so y minus pi over 2 is equal to evaluated in the derivative, which would be negative 2, times x minus my x value, which is pi over 2. So there's my tangent line. And now the only thing that's different from my normal line is I have the negative reciprocal slope. So my normal line equation is y minus pi over 2 is equal to 1/2 times x minus pi over 2. And these are my tangent and normal lines. Okay. All right, so same thing. Now I just have f of x is 4e to the x minus 3 sine x plus x squared, and I'm evaluating it at x equals 0. So step 1, find my derivative. So f prime of x, derivative of 4e to the x is 4e to the x. Derivative of sine is cosine, so I got minus 3 cosine x, and then derivative of x squared is 2x. So I'm going to evaluate in both my function and my derivative. So f of 0 is 4e to the 0 minus 3 times the sine of 0 plus 2 times 0. Ooh. So I'm looking at my derivative. So plus 0 squared. So e to the 0 is 1. So I got 4 times 1 minus 3 times the sine of 0, which is 0. Plus then 0 squared, which is just 0. And I simplify that down and I get 4. And I also need to evaluate my derivative, so f prime of 0. So I get 4e to the 0 minus 3 times the cosine of 0 plus 2 times 0. So again, we know e to the 0 is 1. The cosine of 0 is 1, so minus 3 times 1 plus 0. And I simplify that, that gets me 4 minus 3, which is 1. So I'm going to go ahead and plug in. So I got my tangent line equation. So y minus 4 is equal to 1 times x minus 0. And then my normal line, again, negative reciprocal slope. So the negative reciprocal of 1 would be negative 1. So y minus 4 is negative 1 times x minus 0. Okay. All right, last one. If x is 3, I want to find the limit as x approaches h of the ln of x plus h minus the ln of x over h. So this problem looks horrifying, and it is done in about 3 steps. So a little reminder, the definition of the derivative that we talked about way at the beginning of the unit. Remember, the limit definition is the limit as x approaches h of f of x plus h minus f of x divided by h. So what I can do is I can look right at my problem, and if I kind of compare it to the definition that I have, I see that I have f of x plus h minus f of x over h. So I see that my function is the ln of x. And now what I'm doing is I'm going to take the derivative of that, because I'm given, again, the definition, the limit definition of the derivative. So I'm going to derive it, and then I'm going to evaluate it when x is 3. So I see the derivative of the ln of x. We already talked about this, 1 over x. And if I do f prime of 3, I get 1 over 3. And that is the evaluation of that limit. Again, just working with the definition of the derivative that we talked about at the beginning.